This is section 3 of chapter 10, Math Analysis. We're going to be studying ellipses. I'm your host, Dr. D. Okay. So, we're beginning the juice of chapter 10. Ellipses, a little more challenging than circles because there's more variation in their shape. So the formal definition of an ellipse is the set of all points in a plane, the sum of whose distances from two fixed points is constant. Okay, that sounds kind of crazy, but I'll show you what that means on the drawing. First of all, let's talk about the parts of an ellipse. So, the first parts are the foci. Foci is plural of focus, so we have one focus, two foci. So the foci are the two fixed points that are referred to here. The sum of all points in a plane, sum of whose distance from the two fixed points from the two foci is constant. Now the vertices are plural of vertex. We have four vertices here. So the foci are here and here. The vertices are at the end of each axis. So we have a horizontal axis, and you've got vertices on the ends of the horizontal axis, and then we've got a vertical axis, and so we've got vertices on the ends of the vertical axis. The major axis in this case is horizontal, and the minor axis is vertical. Although we could have this rotated 90 degrees so that the major axis is horizontal and the minor axis is vertical. Or the other way around. The major axis could be vertical and the minor axis horizontal. And later on in this chapter, we're actually going to be rotating these things maybe 30 degrees. Now that'll be major fun. Okay, so let's look at the definition now. The set of all points in a plane, the sum of whose distances from two fixed points is constant. So let's say I take a point here, just a random point on the ellipse, right here. And we'll call that point P. So what I do is I take the distance from point P to the first focus, and then the distance from point P to the second focus. And I add up those two distances. Now, let's say I take another point Q, and it's just another random point somewhere on here. So we'll put Q right here. So now if I take the distance from Q to the focus and Q to the other focus, I add up the red, and that will be the same as the sum of the black. Now let's say I take another point. We'll just take a point down here. Now let's take it over here. This is totally random, so we'll put point R right here. Now the distance from R to the focus and R to the other focus, add up the blues, and it's the same as the reds or the blacks. And this is just so much fun, we got to do one more. Let's take one like over here. So I take the distance from here to the first focus and here to the second focus. So add up the greens, that equals the black, the red, the blue. So that's what it's saying. The set of all points in a plane, so the points are the black ellipse. These are all the points the sum of whose distances from these two fixed points is constant. Another way I could look at this is if I took a string and and put 2 nails in a piece of paper, and then the string was loose enough to be able to go from the 2 nails up to some point up above the axis. Now, if I took my pencil and just moved it as far as the string would let me go in every direction, then I would be tracing out an ellipse. Okay, so that's the basic definition of ellipse. And we're going to be talking about how to get the equation of ellipse in standard form, in general form, and how to go back and forth, how to take features of an ellipse and get those equations. So let's start by defining our distances on our ellipse. Okay, I'm going to show you 2 ellipses now. Nice. Yeah, I just don't like that as well. Let's try to do a better job. Ah, rats. I was doing so well for a second, and then I lost my mind. All right, I'm going with that. It's pretty bad too, but okay. Now, what we're going to do is basically an ellipse is an elongated circle. So here's our circle. It's been stretched horizontal, and so we're going to have a horizontal axis and a vertical axis. Here we have a horizontal axis and a vertical axis. Now we're going to call our vertices A and B. So here's A sub 1 and A sub 2. And here's B sub 1 and B sub 2. So likewise, we've got A sub 1, A sub 2, B sub 1, B sub 2. Okay, now the center is C. Now these are all points, so they're all capital letters. Now then I've got my foci. So I've got F sub 1 and F sub 2. Those are my foci. Now, notice on the ellipse that's elongated vertically, the foci are on the vertical axis. So the foci are always on the major axis. Now, what we're going to do is we're going to say A equals A1C, which equals A2C, which equals 1/2 A1, A2. Okay, so the horizontal axis is A1 to A2. Small a, lowercase a, is the distance, is half of the horizontal axis. Now, B, lowercase b, is going to be the distance from B1 to the center, which is also the distance from B2 to the center, which is also half the distance from B1 to B2. Now that applies to both of these. And C is the distance from F1 to the center, which same thing as distance from F2 to the center, which equals half the distance from F1 to F2. Now, note, C is always on the major axis. Okay, now, the relationship between, well, let's just mark this now. So, okay, so A is this distance right here. B is this distance right here. And C is the distance just from the center to the focus. And then we have our relationship between A, B, and C is C squared equals A squared minus B squared. Or, in the case over here, we have C squared equals B squared minus A squared. Notice that C always equals the major minus the minor, or big minus small. So same thing, we've got big in this case is the B, and small is the A. All right, one more thing that we have to understand for this is the standard form for this ellipse is going to be x minus h 20 squared over a squared plus y minus k 20 squared over b squared equals 1. That will always be the standard form of the ellipse. Now, note, h is always horizontal distance, k is always vertical distance. A is always horizontal distance, and B is always vertical distance, no matter which way we have it oriented. Now, the book does this differently, so be careful. When the book talks about A, it always is talking about the major, or I should say the semi-major axis. So the book, this would be A and this is B. But if we go this way, now small a, lowercase a would be the major, the vertical, and lowercase b would be the horizontal. Now I don't like that because then it's confusing what's A and what's B depending on the ellipse. So in my system, A is always aligned with X and B is always aligned with Y. So the book is going to have two standard form equations. One for the horizontal and the other for the vertical, because the vertical is going to have to be x minus h squared over b squared, which I've always found to be really confusing. So I would rather just relabel it as A is with x, it's always horizontal, B is with y, it's always vertical, and that causes less problems. The only thing you have to know now then is c squared is not necessarily a squared minus b squared, but it's big squared minus small squared. Okay, those are the basic definitions. Now let's jump into the action. So if we have an ellipse, okay, we've got an ellipse. You know what, let's put that on the graph paper. Okay, so the center of our ellipse is 3, 1. And the right vertex is 7, 1. And the bottom vertex is 3, negative 4. What we want to do is write the equation for this ellipse. Okay, so this is kind of like collecting all the data first. So if the center to the bottom goes from 3, 1 to 3, negative 4, that means that's 5 down. Well, so that means I have to go 5 up to get to the other vertex. So that would make this 3, 6. And then I've got another vertex. Well, this goes 4 to the right from 3 to 7. So I need to go 4 to the left, and I would be at negative 1, 1. Okay, so my ellipse is going to look like this. Oh no, I was doing so well on that first quarter. And then I totally lost my mind. Okay. Okay, I like it. Nope, not quite. We'll edit this later. Okay. All right, that's not horrible. So we'll see how you do when you start drawing ellipses. So now, what have we discovered? What else can I add into this? Well, first thing I know is the A distance is 4. So A equals 4. The B distance is 5. So B is 5. Well, now if I know A and B, I know C. So that means C squared equals B squared minus A squared, because it's big minus small. So that means C equals the square root of 25 minus 16. So C equals square root of 9, which is 3. What does that tell us? Well, that tells us that the foci are 3 up and 3 down from the center. So my one focus is going to be 3, 4. we'll call this F2. And then we've got 3, -2. And that's F1. Okay. We really have labeled more than we need to. We were just asked to find the equation of this. So what we do is x minus h 20 squared over a squared plus y minus k 20 squared over b squared equals 1. Well, the center is 3, 1. That means it's x minus 3, 20 squared, over a squared, which is 16, plus y minus 1, 20 squared, over 5, or wait, I'm sorry, over 25, equals 1. That's it, game over. That's our equation in standard form. Okay, so let's try another one. Now this time, we're going the other direction. See, the first problem we were given all the features of the ellipse, and we were asked to get the equation. Well, the next one we're going to take the equation ellipse and graph it and label all the features. Okay, so this time we have x plus 3, 20 squared over 100 plus y minus 4, 20 squared over 64 equals 1. So basically we want to graph this thing and label all the parts. All right, so first part we can say is A is the square root of 100, which is 10. B is the square root of 64, which is 8. H is -3. And K is +4, because it's x minus h and y minus k. And so basically what that tells us is our center is left 3, up 4. There's our center. And the A value is 10 spaces to the right. Now we're going off the page. Okay, let's fix this. Okay. All right, now my C is completely out in the middle of nowhere. All right, so my center, like I said, was -3, 4. And my vertices are going to be 10 right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 10 left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And my vertical vertices are going to be 8 up. Oh, rats. 1, 2, 3, 4, 5, 6, 7, 8. That's it, we're going with it. 1, 2, 3, 4, 5, 6, 7, 8 up there. Okay, so it's going to end up being like this. Okay, there's our ellipse. And now, where are the foci? We have to know what C is. So C equals a squared minus b squared, which is 100 minus 64. Oops, the square root of 100 minus 64. So C equals the square root of 36, which is 6. So that means we know C is in the horizontal direction because that's our major axis. So we go 6 right and 6 left. So here would be focus number 2 and 3, 4, 5, 6. There's focus number 1. So now we've got the vertices are going to be 7, 4, negative 3, negative 4, negative 13, 4, negative 3, 12, and then my foci are going to be 3, 4. My center is going to be negative 3, 4. And my other focus is going to be at, let's see, where are we here? Negative 3, negative 9, 4. All right, so there are all my parts. I've got A is 10, distance from center to right, center to left. That's A. B is 8, distance from center down or center up. And C, small c, is going to be 6, distance from center to right focus and center to left focus. That's it. Okay. Next, we're going to be given an equation in standard form, or I'm sorry, general form, and we have to graph it. Okay, so here's our equation. (4x squared plus 9y squared minus 8x minus 54y plus 49 equals 0. Graph that. Okay, we need to get this thing in standard form or else we can't graph it. So, how do we get it in standard form? The same way we got the circle in standard form. We get our x's together. So we go, our x's are going to be 4x squared minus 8x. And now we get our y's together. So plus 9y squared minus 54y equals negative 49. Okay, now next thing, we're going to be completing the square. We can't have a coefficient of our squared term. So we need to factor that out. So we have 4 times the quantity x squared minus 2x plus blank plus 9 times the quantity y squared minus 9 times 6 is 54 plus blank equals negative 49, oops, negative 49 plus 4 times blank plus 9 times blank. Well, let's see what goes in the blank here. You cut the middle term in half and square it, so you get negative 1 squared is 1. Cut this middle term in half, negative 3 squared is 9. So, what are we adding to the left? We're adding not a 1, but a 4 times 1. So we better add 4 to the right. And we're not adding just 9, we're adding 9 times 9, so we better add 81 to the right. All right, now it's time to get our perfect square trinomials into binomial squared. So we have 4 times the quantity x minus 1 squared plus 9 times the quantity y minus 3 squared equals 81 and 4 is 85, plus negative 49 is going to be 36. Okay, now we have one more step to get this back to the form of the ellipse, and that is divide through by whatever number we have over here on the right. So we're going to divide through by 36, so we're going to have 1 on the right. So I've got 4 x minus 1 20 squared over 36 plus 9 times y minus 3 20 squared over 4 equals 1. Now, if we just simplify this, 4 over 36 is 1/9. So I've got x minus 1 20 squared over 9 plus, now 9, oops. I was thinking a step ahead here. 9 over 36 is 1/4. So y minus 3 20 squared over 4 equals 1. Okay, now what do we have? We have h is 1. That means the center is 1 right. Then k is 3. So the center is 3 up. So there's my center at 1, 3. Now, I know a is square root of 9, so that means I go right 3 and left 3. And then b is square root of 4, which is 2. So I go up 2 and down 2. And the last thing I know is the c squared equals a squared minus b squared. So that means c equals the square root of 9 minus 4. So c is the square root of 5. So that's about 2.3. So if we go, let's get rid of this. We go 2.3 to the right of the center and 2.3 to the left of the center. There's our ellipse. Okay, now when drawing an ellipse, the important thing is the curve needs to be smooth, but also when you get to the vertices, you should have vertical tangents on the left and horizontal tangents on the top and the bottom. So here are foci. There's our center, and then we've got vertices around there. That's it. Okay. Now, there's only one more thing to do, and that's talk about eccentricity. Oh, incidentally, they're going to ask you what the coordinates are for all these things. So you're just going to have to say, okay, the center is 1, 3. The, we'll call this v sub 1, v sub 2, v sub 3, v sub 4. So v sub 1 is going to be 1, 5. V sub 2 is 1, 1. V sub 3, that was v sub 3. Okay. V sub 2 is going to be 4, 3. Yeah, 4, 3. And then V sub 3 is going to be 1, 1. And V sub 4 is going to be negative 3, 3. Now, the center is 1, 3. So that means foci 1 is going to be the square root of 5 short of 1. So that's going to be 1 minus square root of 5, comma 3. And focus number 2 is going to be 1 plus the square root of 5, comma 3. So notice how we list the foci is they're on the horizontal axis, so we're either adding or subtracting them to the x value of the center. That's always going to be the case. Okay, now, one more concept. Eccentricity. Eccentricity is basically the measure of how far away the foci are from the center. Now, the further away they are from the center, the more elongated the ellipse is. So, let me show you what I mean by that. Okay. If we have a long, narrow ellipse, then the foci are going to be far away from the center. If we've got a short, fat ellipse that's practically a circle, then the foci are going to be close to the center. Now, if we have an exact circle, then that means the center will be the foci. So, eccentricity then.
You filming?
Yes.
Oh, okay.
Eccentricity
With Chelsea.
equals c over the major axis. Eccentricity is c over the major axis. And now, notice c is always smaller than the major axis. Actually, to be more precise here, eccentricity equals c over the semi-major axis. So that means E equals c over a for the horizontal major, or E equals c over b for the vertical major. And the other thing that we know is, since C has to be somewhere between 0 and A, let's say, then if I divide through by A, then I've got 0 less than C, less than C over A, which is less than 1. Now, C over A is eccentricity, so what that's saying is eccentricity is going to be a number, a positive number between 0 and 1. So, if I have a large C over A, that means, okay, here would be C is small compared with A. So, small C over A means it's close to a circle. Now, a large C over A is, large eccentricity is going to be a really elongated circle. Okay, so we're going to do one more example problem and then we'll be done. So if I have center is 1, -1. And one focus is 1, -1 plus square root of 5. And eccentricity equals square root of 5 over 3. Find the equation. Ooh, that just gives you a little tingle. Okay, so what we need to do here is we need to first draw our picture, and then we're going to see things pop out that will help us out. So the center is 1, -1. Then we know the one focus is 1, -1 plus square root of 5. So -1 plus square root of 5 is about 1.3. So 1.3 right there. Square root of 5 is about 2.3. So yeah. So that makes it 2.3 minus 1 is 1.3. So this is a focus right here, and this is a center. So right away, that should tell you that the other focus has to be 2.3 the other direction. So, yeah, so 2.3 this direction would be 2.3 right there. So there's my other focus. All right, so this also should tell you that the ellipse is vertical. So that's handy to know. So that means B is the major axis. Okay, what does that mean? Well, that means eccentricity equals B over C. Or I'm sorry, C over B. So eccentricity equals C over B. And what's the distance from the center to the focus is square root of 5. So that tells us that c is square root of 5. So that means that square root of 5 over 3 equals square root of 5 over b. Well, that tells us that b equals 3. What does that mean? Well, that means the distance in the vertical direction from the center is 3. So we go 1, 2, 3, and there's one vertex. And then we go 1, 2, 3 down. Here's the other vertex. See, having the drawing is helping us to see which direction things go and